Alright, so today we're taking a look at how to set up trig ratios. So to begin, here are the formulas. This says sine theta equals O over H, so this would be the opposite side over the hypotenuse side. Cosine theta is equal to A over H, so this would be adjacent over hypotenuse. And tangent theta is equal to O over A, which would be opposite over adjacent. Okay, so this symbol right here that is in front of our trig, sine, cosine, and tangent here, this symbol is theta, and it is a Greek letter that we use here in geometry to indicate whenever we're talking about an angle. Okay, these are the formulas, but a shortcut to help you remember how to set it up would be SOHCAHTOA. Okay, so again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so we're going to kind of color code our notes here. Okay, looking at this example, I'm going to first look at sine, cosine, and tangent for angle A. Okay, so we are focusing on angle A, so this is where I'm going to draw my stick man to help me label my sides OA and H. Okay, so from angle A, labeling our sides, 3 would be opposite, 4 would be adjacent, and 5 is our hypotenuse. Okay, remember the hypotenuse is always across from the right angle. And then O and A move depending on where you draw your stick man, where you're starting from. Okay, so now that we've labeled our sides, we know that sine is sine is opposite over hypotenuse. So for sine angle A, I would use opposite over hypotenuse. So that would be 3 over 5. Okay, cosine is adjacent over hypotenuse. So from angle A, cosine of angle A, I would have adjacent over hypotenuse. So this would be 4 over 5. And then the trig function tangent is opposite over adjacent. So tangent of angle A would be opposite over adjacent, so 3 over 4. Okay, a majority of the time you're going to see your answers written as a reduced fraction, but sometimes we'll also see them as decimals. Okay, so if we convert 3 over 5 to a decimal, that's approximately 0.6. Cosine 4 over 5 here would be approximately 0.8, and 3 over 4 is approximately 0.75. Okay, so now we're going to switch angles, and we're going to do angle C. Okay, so now that I'm looking at angle C for these problems. Okay, so I switched colors, and I'm going to come to angle C, and I'm going to draw my stick man. Okay. H doesn't move. It's always across from the right angle. So H stayed the same, but our opposite and our adjacent changed. So from angle C, opposite now is the side that's 4, and adjacent is the side that is 3. Okay, so if I'm looking at sine of angle C, okay, so from here, sine is opposite over hypotenuse. So sine of angle C would be 4 over 5. Cosine from angle C, adjacent over hypotenuse, so that would be 3 over 5. And then tangent of angle C, tangent is opposite over adjacent, so this would be 4 over 3. Okay, we already know that 4 over 5 is 0.8, 3 over 5 is 0.6, and 4 over 3, when you change that to a decimal, that's 1.33. Okay, so doing another example here. Okay, again, I'm going to look at angle A first here. So if I'm standing up here at angle A, opposite would be 5, adjacent would be 12, hypotenuse is always across from the right angle, that would be 13. Okay, so if I set up my ratios, sine is opposite over hypotenuse. So from angle A, opposite over hypotenuse would be 5 over 13. Okay, cosine is adjacent over hypotenuse. So cosine of angle A would be 12 over 13. And tangent of angle A, tangent is opposite over adjacent, so that would be 5 over 12. Okay, as a decimal, 5 over 13 is approximately 0.38. Cosine of angle A, 12 over 13, that is approximately 0.92. And tangent of angle A, 5 over 12, that is approximately 0.42. So switching my angles. Now I'm looking at angle C here. Okay, so at angle C, I'm going to draw my stick man to show that's where I'm starting from now. Opposite is now 12, adjacent is 5, hypotenuse didn't change. So sine of angle C, sine is opposite over hypotenuse, so that would be 12 over 13. Cosine is adjacent over hypotenuse, so that would be 5 over 13. And then tangent is opposite over adjacent, so that would be 12 over 5. So as a decimal, 12 over 13 we said is 0.92. 5 over 13 we said is 0.38. And then whenever you convert 12 over 5 to a decimal, that's 2.4. Okay, so what you should notice about these angles, okay, sine of one angle is the same as cosine of the opposite angle. Okay, this happens every single time. That's because these angles, remember whenever you switch which angle you're starting from, O and A switch. Okay, so it matches up that way.